Hello, everybody. My name is Keith Maddox. I'm a senior engineer here at Microsoft, and I'm so excited to be able to talk to you today about how to move from Ingress to Gateway API with minimal hassle. Don't know what those words mean? Well, you're about to. Let's dive right in. Now, as you may have heard, Gateway API is a new standard for layer 7 traffic management in Kubernetes. The Ingress API is not going away. Ingress API is what actually one of the original Kubernetes distributions shipped with. It's one of the earliest resources in all of Kubernetes. And it's not going away. It will always be in every future version of Kubernetes. It's not going to be removed. However, if you go to the Kubernetes website, all development in the Ingress API has been frozen. And all new development, all new features, new adoption efforts are being redirected to this new thing called the Gateway API. We're going to talk more about the specifics of Gateway API in just a little bit. But what I'll say now is that it is a far more sustainable API. Features like HTTP retries and traffic splitting are going to be consistent, going to look the exact same no matter which of the 20 plus implementations that you may be using. If you've used Ingress in the past, you're probably used to a ton of implementation specific annotations for you to use functionality of your Ingress controller to do those exact same things like retries and traffic splitting. Just my opinion, but that's no way to run a platform. Today, I hope to help you figure out how to get away from that reality over to Gateway API. Now, when you look at the title of this presentation, maybe when you heard me say minimal hassle, you may have thought about something like this, that this Keith guy works at Microsoft is going to give me this simple technique, this one neat trick that's going to make this migration of mine completely painless. Well, I regret to inform you that this is not that. And in fact, I'd go so far as to say that a one simple trick for migration doesn't exist. I wish I could tell you that, but it's just simply not true. Every migration has risk. Every time you're changing your infrastructure, specifically your networking infrastructure, you have to do so in a very careful way. My goal today is to give you a strategy that's going to help you and your organization head into this migration with all the tools that you need to be successful. Now, let's start with a refresher on the Ingress API. I've got an example here on the right side of the presentation. You can see this Ingress resource that many of you watching this might be very familiar with. And one thing I want to point out is that even though we talk about the Ingress API in a singular tense, it's actually two resources baked into one. You've got your Ingress resource. That's what we've got here on the right side. And the Ingress resource's job is to describe the usually layer 7 traffic routing logic for your application. By the way, when I say the words layer 7, I'm referring to usually HTTP traffic. We're talking about application level traffic above just TCP and IP. So here in this example, what we can see is that there's an ingress resource that lives in the default namespace. It's this very minimal ingress, hence the name. And it's got some routing rules. It's got one routing rule, in fact, that is happening at HTTP. And it's going to be routing based on the path of incoming HTTP requests. If the path has a prefix of test path, then the ingress controller is going to kick into action. It's going to route that traffic to the test service backend. That's this ingress resource in a nutshell. And that's what generally all ingress resources are going to be doing at their core. Taking a HTTP request, usually doing some sort of routing logic and sending it to a backend service in Kubernetes. There is, however, another resource in this equation that's not pictured here, but it's called the ingress class. And the ingress class is a registration mechanism. You see, we refer to this ingress class name in the next example. Well, that ingress class name refers to the name of an ingress class resource that your platform admin or your SRE it's going to be deploying inside of your cluster. Most app devs typically only look at these ingress resources for a reason, but I just want to point out that there are two resources at work here. Like most other things in Kubernetes, the Ingress API represents declarative configuration for some piece of infrastructure that's responsible for bringing traffic into your cluster. This is often looks like a cloud load balancer, But if you're running on-prem, this could be an F5 appliance that is doing some routing. Maybe you're a hobbyist like me and you've got some Raspberry Pis in a home lab somewhere that's running Kubernetes. Well, I'm using at my house, I use Metal LB to route traffic into my Raspberry Pi cluster, and that could be Ingress as well. Whatever that infrastructure looks like for you, Ingress is responsible for taking configuration from you as the user and programming that infrastructure to route traffic appropriately. And like I mentioned earlier, this API that I'm showing you right here was marked as frozen about a year and a half ago. New features are going to be developed in Gateway API, but there are also some, how should I say, rough edges in this with this API when it comes to multi-tenant or multi-role environments. In a multi-tenant setup, maybe I've got multiple customers deploying infrastructure or applications into the same Kubernetes cluster. Well, with Ingress, you can have there's no like scoping. There's no how do you say direct linking between an Ingress resource and a specific load balancer. You can't like specify one versus the other in a very easy way. So if I'm running with multiple customers in the same cluster, they're all running Ingress resources, often targeting the same piece of infrastructure. That gets really scary and potentially when you start thinking about one application team or one customer, excuse me, writing a traffic routing rule that's now potentially affecting another customer because the ingresses are all merged together. Similarly, if you've got a multiple persona, multi-role environment, like maybe you've got three or four or five or 200 application teams working in the same set of clusters, one app dev team needs to expose their service to all HTTP traffic that starts with slash API that needs to go to that service. But another application team might also want to route traffic to things that have slash API slash V2. And if the routing rules aren't written just right, it's really easy for those to conflict and to cause an outage. The Ingress API doesn't have a lot of tools built into the API to help you navigate and to manage that. However, Gateway API was built from the ground up to solve some of these problems. It is the successor to Ingress, not just spiritual successor. It is fundamentally the successor to the Ingress API. It started back in 2019, and about a year ago, it graduated to generally available status. That means that you have API guarantees. It means that you can go to the Gateway API community to get help and support. And but at the time of we're recording this, there are over 20 implementations, I think 24 specifically last time I checked, that implement the Gateway API. Versus the Ingress API, I don't think there are that many active Ingress API Ingress controllers today. And so, one of the very interesting things that has allowed Gateway API to be so successful is that they're distributed as CRDs instead of being baked into Kubernetes. Now, like, what's a CRD? A CRD is a custom resource definition that you can go and install inside your Kubernetes cluster. If you're using Kata or other Kubernetes things, you're probably utilizing custom resource definitions yourself. You might even be writing your own custom resource definitions to operationalize and manage your Kubernetes cluster. And Gateway API is no different. To start off using the Gateway API, you're going to install the CRDs that are released by the Kubernetes community. And what this has allowed the Gateway API community to do over time is to rapidly iterate and add a lot of functionality and test things out in a safe way before marking them as standard or stable, while still getting, as we see, wide adoption with 20 plus implementations. The CRD aspect of the API is to thank for much of that iteration. The philosophy behind Gateway API is that rather than having every implementation have its own suite of annotations, well, Nginx is going to have I think, anywhere from 50 to 75 annotations for modifying implementation specific things like max concurrent streams for HTTP2 or sticky sessions or retries or things like that. Whereas Contour might have its own set of annotations for its ingress controller. Instead of doing that, Gateway API seeks to try to standardize strongly typed fields for the same functionality. And this means that the API describes has a lot less things that are standard, But when you do have a standard gateway API piece of functionality, you know that it's going to be unified across all the 20 plus implementations. There are still extensibility mechanisms, so the different gateway API implementations can add on their own things. And in fact, there are some things in the gateway API specification that are what we call extended support. So some implementations might run ahead of the others and implement things in a different way. However, you still have the compatibility promise. As long as you stick to that core API, you're guaranteed compatibility with all other API implementations. Lastly, speaking about the security aspect of this, Gateway API is built for multi-tenant scenarios. We see here on the right side this diagram that I've become plenty familiar with in my time working in the Gateway API community. Um, each resource within the Gateway API family of resources is sort of targeted toward a specific persona, a specific role that might exist within an organization. The gateway class is going to be created by the infrastructure provider. That's actually probably not you. The infrastructure provider is going to be your cloud provider or your gateway implementation, like Contour, like Istio, like Ingate, whatever your implementation is. It's going to create likely a gateway class for you to use and to build off of. Then from there, your cluster operator, that's your SRE, your platform admin, your DevOps administrator, that cluster operator is then going to create a gateway for you. And a gateway is going to refer to a specific, usually a specific piece of infrastructure that is bringing traffic into your cluster, similar to the ingress that we talked about before. Only usually the cluster operator is going to be creating that gateway because there's going to be maybe a load balancer cost associated with it, et cetera. The cluster operator role is responsible for creating that gateway and then binding that gateway to the gateway class that your Nginx, your Istio, your Kong controller is going to create for you. And then your application developers who are developing these services are able to then write routes that describe the way that incoming traffic should talk to their service. This group of application developers here on the very bottom has an HTTP service. And maybe there's encryption being taken care of by some sort of service mesh, or maybe it's being done in the library. Regardless, they are writing an HTTP route and say, hey, to talk to our two services down here, you're going to be using HTTP. And in that HTTP route, they're going to have retry policies. They're going to have maybe some traffic splitting, some header rewrites, et cetera. That's all going to live in this HTTP route that's here. But over here, this group of application developers has the ability to say, hey, you're going to communicate to our application via TLS. And you're going to need to, we're going to describe how the TLS is going to go through. Is it going to be passed through? Do we expect the gateway to terminate TLS or with a kind of classic SSL style interaction? Um, that application developer team is not going to conflict with this application developer team the way that their specs are written. And both of those resources are going to be bound to this gateway. So again, from the ground up, Gateway API was built for complex scenarios like these, where you can give different RBAC permissions to different groups of people in your organization, and have them all collaborate without as much fear of them stepping over each other. So hopefully by now you're starting to hear just how great Gateway API is. Not only the fact that it's going to be allow you to grow in a way, or rather, it's going to allow your infrastructure to grow in a way that matches your organization, but also the new features that are coming into Gateway API in a standard way are just are fantastic. So hopefully you're hearing this and you want to switch. There's only one problem with that though. Who likes migrations? You tell your nearest sysadmin or platform engineer or SRE that you want to go undergo a migration, and they're going to hit you with a face that looks like this, or something like this. Like who, if you've been through a migration, you know this feeling well. This is not something that you want to repeat. Nobody wants to do this very often. And the reason for this is pretty plain, right? It's pretty simple. Migrations introduce change into your system, and change equals risk. Um, so when you are on the hook for that, introducing that risk to your organization, you better have a good reason why, and you better have a strategy for doing it in a safe way. That's what we're here to talk about. How do we know what Gateway API provides. We know that Ingress is not necessarily what people should be using for new development in 2025. So how do we set ourselves up for success moving from Ingress over to Gateway API? Here's a couple of tenets, a couple of principles that have helped me throughout my career and my experience to be able to do migrations in a safe way. First step is plan to succeed through failure. Um, what do I mean by this? No operation is going to be 100% foolproof. None. I don't care if you are the best ops team in the world. Zero failure migrations, especially from without rehearsal, without practice, without a strategy for dealing with the failure, doesn't happen in this industry. Even the best networks in the world only have a certain number of nines of reliability. Failure in some way is almost inevitable. So the idea behind this principle is to prepare for it. Figure out how you're going to respond when things do inevitably fail. Analyze your system, figure out what those failure domains are, and then create a process for making sure that you can identify those failures, ideally before they happen, but if it, when it happened, as close to when it happened as you possibly can, and make sure that everybody in your organization is integrated with that practice. If you look back at this Gateway API breakdown, there are lots of roles that exist within your organization. This is just a couple of, maybe two or three of them, but don't forget about your security team, your compliance organization. Maybe you've got some data scientists that are in there who are consuming things, especially in this era of AI. There are lots of different roles in your organization, and everybody, no matter what role they're in, needs to be on board with this culture if they're going to be touched by this migration. So plan to have failures, and then figure out how you're going to succeed through that failure. Sort of following along that, data is just incredibly important to making this go successfully. You've got to confirm how you're going to observe the system before you can know how to detect the failure and how to respond to the failure, and then how to evaluate if your strategy worked. So if you don't have an observability strategy in place, if you're not observing the right things, if you're not having metrics and logs pipe through and show you, what your SLO is for a particular service, if you don't have a whole strategy sort of set out before you start your migration, you're sort of asking for things to go wrong, and you're asking for chaos essentially. Before anything changes, you have to have an observability strategy. And again, I know a lot of this sounds like sort of traditional change management sort of strategies, but it's easy to forget about those things that have gotten us as an industry so far, have gotten us here, because we're working with a lot of new technology. Change management is still effective with cloud native technology, and the goal here is just to try to marry them together. One of the things that is a little bit harder to do is to figure out like what tools you have at your disposal to be able to aid in the migration. How can you cut down the amount of manual work and toil that your teams have to do to be able to make the migration successful? I'm here to talk to you about just three different tools, and more might be, who knows, in a year there might be even more tools, but these are three that I know of, two of which being supported by the Kubernetes community. The first is a tool called Ingress to Gateway. Ingress to Gateway is a CLI tool that actually has the ability to look at Ingress resources in your cluster and spit out Gateway API resources. It can do this for the amount of functionality that might exist, that does exist in Gateway API and Ingress. Some of those more advanced and sort of niche annotations that might exist in your personal Ingress controller might not be present in Ingress to Gateway, but the great news is that it's open source and that more contributions are typically welcome in the tool. So Ingress to Gateway is a great starting point. Like I wouldn't deploy what it spits out immediately, but if you're not familiar with the API, if you're feeling a little bit overwhelmed with all the different resources and their interactions, Ingress to Gateway is a great way of looking at your existing Ingress deployments and then seeing what would that look like in Gateway API, to talk through that with your team to see who owns what and what that workflow would look like. And if you stick around, there's a demo here at the end of the presentation that we're going to look through exactly what Ingress Gateway is going to spit out for you. A CDN is sort of the second tool that I like to talk about because they're extremely powerful. Whereas Kubernetes is one context that sort of sort of atomic, meaning that you can't really break down things beyond a Kubernetes cluster. A CDN is able to look at multiple Kubernetes clusters. So even if you did something like have, instead of migrating from Ingress to Gateway API in one cluster, maybe you do Ingress in one cluster and Gateway API in a new cluster. You can use a CDN layer to route traffic intelligently between those two clusters as you go through your migration. So don't discount classic tools like a CDN that will allow you to do these things gradually over time. And then lastly, Gateway CTL. Gateway API has, like I said, a lot of resources. It also has a lot of policies. Gateway CTL can provide you a easy to use CLI interface to inspect your Gateway API deployments, to monitor it, to get an understanding of what's deployed where. And this also is supported by the Kubernetes community and is also open source. And contributions for anything you think might be useful are often are just an issue away. We love interacting with the community, with people like yourselves who are looking just to try to make their lives easier. We love to help you be able to do that. Last couple of points here as far as principles. Figure out who in your organization fits what Gateway API persona. There you might be an enterprise with hundreds of thousands of technology professionals. There's going to be a lot of responsibilities to keep in mind when it comes to Gateway API. Figure those out early. Maybe you were a startup and your infrastructure department is one, maybe two people. Figure out how you can make that person's life easier, but also keeping in mind that as you grow, every startup must prepare for growth. Maybe you need to grow to adopt multiple different roles, and Gateway API is equipped for you to be able to do that in a seamless way. And then lastly, reach out to the community to figure out what the best practices are. If you're watching this, probably are not the first person. You won't be the last person to undergo an Ingress to Gateway API migration. We love to work with you to maybe talk about through some case studies to see what went well, and provide those to the community to help the next person go through their migration in an even easier way with more best practices that are extracted and put in public for folks to see. So those are the high-level principles. Like I said, no one easy trick, just solid engineering and change management principles that have been in use for decades. They'll still help you here. So now we're going to look at a demo of one of the tools that I just mentioned a little bit ago, the Ingress to Gateway CLI tool. Like I mentioned before, this tool is a very useful CLI that you can go and download from github.com/Kubernetes SIG/Ingress to Gateway. And so before we get too far into the demo, we're going to set the stage. So I'm going to do a kubectl describe of my cluster to see what we've got, what services we have deployed. You can see we've got the HTTP bin service listening on port 8000 in the default namespace. Now we're going to look at our Ingress resource. The Ingress resource, as you can see here, is using the Nginx Ingress class, and it's got a single rule that says for HTTP traffic that comes in that has host www.example.com, and the path is the root path, redirect all that traffic to HTTP bin colon 8000, so the HTTP bin service on port 8000. Pretty basic and minimal Ingress resource. It's about what we expect. So now let's see what Ingress to Gateway can do with this very minimal resource. So we're going to just skip ahead to using the Ingress to Gateway CLI. So again, you can get this from GitHub, download the release for your OS. What we're going to do is we're going to use this print command. So Ingress to Gateway print. We're going to pass in a specific provider. And that provider in this case is going to be Ingress Nginx. Ingress Nginx is the particular Ingress controller I was using, and Ingress to Gateway has support for the Ingress Nginx Ingress controller. Do the translation from it. Ingress to Gateway, by the way, has support for multiple Ingress controllers. Istio, Ingress Nginx, and I think at least one other Ingress controller. So if you don't see yours there, PRs are welcome, and also feel free to open an issue to get maintainers to help you get your Ingress controller added to the tool. But anyway, in this example, we've got Ingress to Gateway print And we want to print out that configuration here. And the provider is Ingress Nginx as the Ingress controller. So notice we didn't pass in any YAML files. We didn't have to do any Helm templating. Ingress to Gateway was able to use our local kube config, the default kube config, to look inside our cluster and to see what Ingress resources were deployed. It's taken those and turned those into Gateway API configuration. Notice that the gateway class name of this gateway that was created is equal to Nginx, the same thing as our Ingress class name. But Ingress to Gateway gave us this gateway that we could deploy. And if you've got Ingress Nginx as a gateway API controller, this gateway class will, or this gateway will create some infrastructure for us to be able to get traffic into our cluster. This gateway has a single listener. So that's the port that the gateway is listening on. In this case, it's port 80. Gateway API also allows you to specify a host name qualifier on the listener. So in particular, this gateway only will accept traffic on port 80 if the host name is www.example.com. We also have HTTP route. Ingress Gateway is smart enough to know that if we have that the Ingress resource actually is going to break down into a gateway and an HTTP route. If you remember all the way back in the slideshow, we look at the Gateway API hierarchy of resources. We saw that HTTP bin, or sorry, not HTTP bin, HTTP route was descended from the gateway resource. There's a link between your gateway resource and all of your routing resources, HTTP route, TLS route, etc. We can see that relationship expressed here via the parent ref of the HTTP route. That parent ref name, the parent ref link is via the name of the gateway. And you see the name of Nginx here matches the name of the gateway resource. So that hierarchy is expressed via parent refs. This route has a hostname matcher. So similar to the listener up here, the hostname matcher for the route is www.example.com. So only traffic with that host header is going to match. And then we've got our routing rules, and the traffic has to match at least one of the routing rules in order to be appropriately forwarded. And here for this routing rule, if the matching criteria is met, the traffic will be routed to the HTTP bin service. This backend ref is matching a service by default. And it will route to the HTTP bin service on port 8000, which is where we saw the service listening on in our very first command in the demo. Then we have our matching criteria. In this case, we just have one single matching criteria, a path prefix matcher with value slash. This means anything with the prefix of slash is going to be matched by this HTTP route, which is 90%, 99% of the traffic that would be coming through the gateway. So you see, we started with an Ingress resource and a service inside of our cluster. And Ingress to Gateway gave us a great scaffold, a great starting point in order to start our migration and get it underway. Now, going back to our presentation, just to briefly finish up, I want to just thank you for your time. Hopefully, these change management principles combined with cloud native technology and the open source community of Gateway API will help you feel like you're equipped to make the change from Ingress API to Gateway API. There's no one simple trick, but these principles help us to do so in a safe manner. I appreciate your time, and hopefully there is a very low stress migration headed your way in the future. Thank you so much. Have a great rest of your day.